Quadratics! Learning Target 1 and 2, Episode 2 of Season 6. We will be looking at different forms of quadratics. So far, we have actually only looked at vertex form, but we will be looking at all three and kind of looking at what does each one tell us, what's kind of the important information easily given away by each one. So we'll start with vertex form since that's the one that we actually know. Here is the big fancy mathy way of writing vertex form. It's y equals a times x minus h squared plus k. And an example of that, or a couple examples of that, y equals 2 times x minus 4 plus 10, y equals x plus 1 squared minus 4. If you need to pause to get any of that down, feel free as always. The first thing that this tells you is in the name. Obviously, it tells you the vertex. We can figure that out from basically looking at what we did when we first started talking about translations. Right here and right here. These were the two parts that when we looked at translations, we said, okay, how do I get the vertex back to 0, 0? So these two numbers right here tell us what the vertex is. The second thing it tells us which way it opens. You'll notice that on this first one there's not a negative, so it has not been reflected at all. So this one has to open up. This one also, and I forgot to put it on here, but this one also tells you the scale factor. And that scale factor is right there, A. And you've seen that before too with the different transformations you've done. In this case, we would have a scale factor of 2, and we have translated this to the right 4 and up 10, giving us a vertex of 4, 10, and a scale factor of 2 if we're just looking at this example. Alright, so that's the one you are most familiar with. These others, we'll do general form next. It's just y equals ax squared plus bx plus c. An example of that, 2x squared plus 6x plus 10. The first thing that it tells us is the y-intercept. If you look right here on the end of the general form equation, the plus c, or in this case plus 10, that gives us the y-intercept. Alright, so the y-intercept just comes from right here, plus c plus 10. The reason for that being, and you don't have to write this down, but just pay attention to what I'm saying and this will become obvious for you. A y-intercept always has an x value of 0, right? You've known that for a while now. If I take a 0 and I plug it in right here for x, you get a times 0 plus b times 0 plus c. A times 0 is just 0, so we're ending up with y equals 0 plus b times 0 is 0 plus c, which pretty much gives us a y value, y equals c. So the y-intercept is at 0, c, and in this case c is 10. So this gives us a y-intercept of 10. And it's just that in general form it's the number that's just on the end there, the constant number, no x. Again, it tells us which way it opens. In this example, we do not have a negative here, so this was not reflected, so that opens up. And it also, and I forgot it again, but it tells you the scale factor. and in this case, again, it's 2. The coefficient on the x squared term, we mentioned this in class briefly, very briefly, so I don't expect you to remember it, but the coefficient on x squared is going to be your scale factor. So in this case, it's 2. Factored form. This one looks the most different of the three. It says it's written as a product of expressions. So x minus 6, that's an expression. X plus 3, that's another expression. Product means multiply, so we'll multiply between them. This is a factored form here. X minus 6 times x plus 3. The first thing that this tells you are the x-intercepts. All right, if you look at this first example, x minus 6 and x plus 3, an x-intercept occurs where y is 0. X-intercept occurs where y is 0. So if y is 0, then, and this is something that we'll get into later, the x-intercepts are actually going to be 6 and negative 3 in this case. 6 and negative 3. And that comes from where when y equals 0. If that's confusing for you, where I got the 6 and negative 3, don't worry, because we'll figure that out in our next few learning targets. But for now, what you need to know, what the most important thing for you to know, is that factored form gives you the x-intercepts, or roots or zeros. Remember, those are the same thing. Again, it tells you which way it opens. We don't have a negative out in front of all this parenthesis stuff, so this one's going to open up. There is a way to get scale factor off of this, but it's a little bit more difficult, so I want to just leave that one alone for now. So we won't talk about scale factor, even though it is possible. So we're just going to kind of leave that one as it is. Factored form gives you x-intercepts and which way it opens. Pause this page if you need to write anything down. Ask questions on the question form if one or more of these are confusing for you. And if you just need more examples, then just say, hey, I need more examples. Example here. We're going to write the equation for this parabola in the 3 different forms. I'm going to start with vertex form because that'll be the easiest for us. The vertex here is at -1, -8. So if again I'm thinking of a way to get this back up to the origin, this would be y equals, I'm going to leave a little bit of a blank there in case there's a scale factor. But this is going to give us y equals x plus 1. I would have to add 1 to the x. And x plus, x minus 8. So that's what we've got so far. A scale factor we can now figure out. Let's use this point right here. Looks pretty nice. And this one right here. So we've got a change in x of 2 and a change in y of 2. Normally over a change in x of 2 we get a change in y of 4. So this would be 2 over 4 or 1/2 for the scale factor. Okay, so there's our vertex form. Let's do, we'll do general form next. This is going to look like y equals something x squared plus something x plus something else. We can figure out a couple different things just by looking at the graph. We know that this is going to be a 1/2 x squared because we already know the scale factor is a half. We know that the y-intercept is going to be this number over here, and we're not quite sure what that is, but it looks like it might be about -7.5-ish. But what we can do is we can take our vertex form and just use some simple algebra steps, and I'm going to get that out of the way for a second. Use some simple algebra steps just to rewrite it. So take vertex form, y equals 1/2 x plus 1 squared means times itself, minus 8. We know how to do this x plus 1, x plus 1. That goes back to FOIL, first outside, inside, last. So what this is really going to end up being is 1/2 x plus 1 times x plus 1 gives you x squared plus 2x plus 1 minus 8. Then go through and multiply each by a half. Y equals 1/2 x squared plus x plus a half minus 8. Y equals 1/2 x squared plus x minus 7.5. It is now in this last form that we wrote right here. It's now in general form. So that is what our general form looks like. I'm going to go ahead and get rid of all of this. All those steps in between were just algebra steps. That's all just rewriting the equation using the different properties, multiplication, division, addition, subtraction, all that different kind of stuff. And I will go over that in more detail because that was, I know I went quickly through it. So there is our general form. The factored form. The factored form we just get from scale factor, x something, x something. We already know the scale factor is a half. These parts are very, very easy to fill in. They come exactly from the x-intercepts, or the roots or the zeros if you want to call them that. And it doesn't matter which one goes where. So we can put this 3, we can put it in this spot. I'm looking exactly the same as the vertex. How do I get this back to 0? What did it do from 0 to here? To go back to 0, I subtract 3. To go from here back to 0, I add 5. Or you can think of it as the opposite of whatever this is. The opposite of -5 is +5. The opposite of 3 is -3. And that's how we can get factored form. So I know that going through that was pretty quick, especially general form. We will do plenty more examples of this in class and in your focus problems. So if that at least made a little bit of sense to you, that's the goal of this video. If you're to the point where you think, given a couple examples, you could probably do this, then you're on track. The before class, this gives you vertex form right here. And I just want you to try to rewrite it in general form. So you're going to want to take care of this squared part first and square the x plus 3, multiply everything by 2, subtract 5 at the end, and you'll have it in general form. Alright, so give that a try, see what you can do with it, and we will go over it in class.